and welcome to our insightful discussion about a fascinating topic. Today, we're going to discuss ancient and modern astronomy. So come and join us as we embark ourselves on this topic.
Imagine if the ancient world didn't make any discoveries. Will the people of today had to start discovering without any prior knowledge?
Thankfully, the ancient Greeks had an explosion of astronomical discoveries, which makes them the major contributor of the ancient astronomy.
The Greeks wanted to know the answer to one big question. How does the universe work?
Come on, let's dive deeper.
The first discovery about the Earth is that it is spherical. Yes, you got it right. Earth's true shape is an oblate spheroid. This just means that it flattens at the poles and widens out at the equator.
During a lunar eclipse, two Greek astronomers, Empiricus and Anaxagoras, found the Earth's shadow in the moon. They saw that the shadow was clearly circular.
Even Aristotle believed the universe was spherical and infinite. He observed lunar eclipse and noticed a round sphere that could amplify a circular shadow.
Most ancient Greeks believed that the Earth was round, but they had no idea how big the planet is until Eratosthenes devised a clever method of estimating its circumference. He measured the Earth's circumference using a stick. He used his knowledge of the distance from Alexandria to Syene to calculate the circumference of Earth to be approximately 40,000 kilometers.
Have you ever wondered why the moon's forms are different? Anaxagoras realized that the moon phases were the result of different portions of the celestial object being illuminated with the sun from the Earth's perspective.
In simple terms, the phases of the moon are caused by the changing position of the moon, Earth, and the sun. As the moon goes around the Earth, different parts of it are illuminated by the sun. Who were the other astronomers who had major contribute in astronomy discovery?
Aristarchus was an ancient Greek astronomer and mathematician who was presented the first known heliocentric model. It proposed that the sun is the center of the universe. It means the Earth rotates on its axis and revolves around the sun.
Hipparchus was a Greek astronomer, geographer, and mathematician. He is considered the founder of trigonometry, but is most famous for his incidental discovery of the precession of the equinoxes. He made a compilation of 850 stars and developed a method for predicting lunar eclipses. Claudius Ptolemy was an Alexandrian mathematician, astronomer, astrologer, geographer, and music theorist. He proposed the geocentric model or Ptolemaic system that says the sun, moon, and other planets move in a circular orbit around the Earth.
Telescopes were just recently invented. So how do you think they observed back in the ancient days?
To observe the motion of the sun, Babylonians and Egyptians used a gnomon. It is an early astronomical instrument consisting of a vertical shaft, column, or the like. It is to determine the altitude of the sun or the latitude of a position by measuring the length of the shadow cast at noon.
Now, let's talk about the phases of the moon.
New moon. This is the invisible face of the moon, with the illuminated side of the moon facing the sun and the night side facing the earth. Waxing crescent. In the northern hemisphere, we see the waxing crescent phase as a thin crescent of light on the right. First quarter. We see the first quarter phase as a half moon. Waxing gibbous. Waxing gibbous is between the half moon and the full moon. Waxing means getting bigger. Full moons. You can see the moon completely illuminated during full moons. Waning gibbous. Waning gibbous is between the full moon and the half moon. Waning means getting smaller. Last quarter. We see it as half moon too, but the opposite half is illuminated. And lastly, waning crescent. In the northern hemisphere, we see the waning crescent phase as a thin crescent of light on the left.
We are done with the phases of the moon. Now, let's move on to eclipses.
Eclipse occurs when one object gets in between you and another object and blocks your view. From Earth, we experience two types of eclipses, an eclipse of the moon and an eclipse of the sun. A solar eclipse happens at just the right moment. The moon passes between the Earth and the sun. This can be only happens during new moon. There are three types of solar eclipse, namely partial, annular, and total. A lunar eclipse is a astronomical event that occurs when the moon moves into the Earth's shadow, causing the moon to be darkened. This can only be happens during a full moon.
Now, let's learn the motion of the stars.
Diurnal motion is a daily motion of the sun, moon, stars, and planets that appears to move across the sky. Annual motion is the apparent yearly movement of the stars as observed from the Earth as a direct effect of the Earth's revolution around the sun.
Even before the invention of telescopes, there are planets that was already discovered. Mercury, Venus, Earth, Mars, Saturn, and Jupiter.
At last, we are done with ancient astronomy. Now let's dive into the modern astronomy.
Tycho Brahe was a Danish astronomer and nobleman who made accurate observation of the movement of celestial bodies.
Explained that the Earth is the center of the universe. The moon, sun, and star revolve around the Earth, while the other planets revolve around the sun.
Tychonic system is a mix of heliocentric and geocentric models. That is why the Tychonic system is also called the heliogeocentric model. Fascinating, right?
Johannes Kepler was a German astronomer, mathematician, and astrologer who was Brahe's assistant. When Brahe died, his data enabled Kepler to formulate his laws of planetary motion. Note, they had an unsteady working relationship. Here are the laws of planetary motion. First, the law of ellipses. Kepler postulated that instead of a circular path, planets follow an oval or an ellipse orbit. The law of equal areas stated that when an imaginary line is drawn from the center of the sun to the center of the planet, the line will sweep out an equal area of space in equal time intervals. Last, the law of harmonies. It describes that the square of a planet's orbital period is proportional to the cube of a planet's average distance from the sun.
And that's it for ancient and modern astronomy. I hope that you have learned and enjoyed our video. Before we end, I would like to give you a quote. Man must rise above the earth to the top of the atmosphere and beyond, for only thus will he fully understand the world in which he lives.